The following content has been provided by RWTH Aachen University.
The very first system that moved beyond this sort of special purpose stuff was called Sketchpad. And Sketchpad was another sort of key event in the development of interaction models. What happened there was that Don Sutherland came up with the idea of having a more general purpose interactive computer graphics program. So this was the first system in the world that presented ideas for general purpose interaction with graphical content on a screen, including things like satisfying constraints. What I mean by this will become clearer when we look at the video. So this video was made by an MIT science reporter. He's basically a guy who was running around MIT and interviewing the crazy researchers, what they were up to. So this interview will seem kind of forced, but he's trying to draw the interesting things out of that researcher who has a hard time explaining this to the common folk. You'll see two-dimensional drawing. You'll even see three-dimensional drawing, CAD basically. You'll even see graphical programming in the last part of this video. So let's check out this video. So a couple of things we saw here already was, first of all, what you noticed was this was basically, like AutoCAD, Illustrator-like interaction. Happening, however, back in '63, so even the invention of the PC is sort of another like 20 years down the line, right? Hasn't even happened yet. What surprised me about this in particular was that did you notice anything about the interaction, the first part, when he was manipulating this like wedge on the screen? Was there something that you noticed that you couldn't even do today with like Illustrator? Yeah?
Could pick one point and move the lines with it.
So there was a certain sort of constraint, what basically like the lines were anchored. If you moved one, they were sort of magnetic, as we would say today in the interface, and the others moved along with that. Yeah, well, that's something that you get today as well, right? So you can basically have multiple lines, and if they're latched to the same anchor point, and you grab that anchor point, they will all move along. Yeah.
Use references of the objects you have drawn earlier.
Okay, so there was this idea of sort of a reference, or master and copy as he called, and it wasn't really a dumb copy, it was actually sort of a smart link to the original object. So you change one master and then, or template if you like, and then all the occurrences of that change. But even that's something that, maybe not Illustrator, but tools today support. I'm talking more about the actual sort of manipulation of the objects, the way that you interacted with them, yeah.
I think we have breaking digitizers, but these are still pens we just put on the display or right on the display, and we have this. It looked just like a gesture-based system.
Okay.
The pen with the air gap between the display, and actually could move it. And these are things now finally with lead motion or whatever are
Okay. So you notice the light pen doesn't need to actually touch the display. It's sort of manipulated slightly in front of the display. That might be a good thing or a bad thing, depending on whether you want to rest your hand while you're sketching or whether you want to stay away from the screen. You're right, but mid-air interaction sort of is just now coming back into the interface. There was something else. You may have noticed this. At some point, he took the wedge and he changed its scale and moved it somewhere else and also changed its rotation. Did you notice anything about that particular interaction? Yeah?
I'm not sure, but he doesn't work actually with pixels where he's manipulating the colors. He works with vector-based.
Okay, yeah, so this is a vector-based system. So the computer basically has a list of lines that it draws every time it refreshes the oscilloscope. And so this is a vector-based drawing engine behind the scenes. We'll talk more about that technical part of how these systems worked in designing interactive systems too next semester. But yet something else. Maybe it was so natural that you didn't notice it. But let's say you want to move scale and rotate an object with like Illustrator today, how do you do it? Yeah.
You choose the function,
Yeah.
and you do it.
Right. So you choose move, then you move it somewhere else. Then you click on like the scale tool or whatever, and you use the scaling. Then you maybe click on rotate, and you do that. He did all these things at the same time, at least two of them. So at some point he moved with the right hand, he had his light pen, moved the object from here to here, and with a knob, a physical knob, a dial on the scope or on the system, he at the same time changed the rotation or the scale. So there was a sort of a bimanual interaction going on that we're beginning to see coming back now with multi-touch interfaces, right? Where you can take a picture and like take two fingers to rotate and scale at the same time and move at the same time. But for the longest time, we had reduced the richness of interaction of people with the computer, even with a mouse, to basically me only having one finger to poke at things and do one thing at a time. I had to select tool after tool after tool to do individual interactions, which is not at all what we do in real life. And if I have a piece of paper here and I want to turn and move and scale or rotate and move it, I'm not going to first just move it there and then rotate it, right? I do all these things in one go. And that was sort of possible with this system already, and is now only coming back with what people call, natural interaction with touchscreens and so on. So I'm going to try to jump back into the video here. Okay, so then the other thing you may have noticed in the 3D stuff, that was actually sort of, hidden line algorithms running on this system, right? Hiding stuff behind the scenes. Of course, you saw all the things like constraints of jumping on what we now call sort of snap to grid, basically, or snap to point was implemented in this drawing program already. And we're now going to get to the last part where they're doing sort of visual programming. So in this last part, I was surprised when I saw this the first time because that's essentially sort of like visual programming or flow chart-based programming. So like he says, like other people use punch cards to program the computers. We're not going to do that. We're not going to even code in text like most of us still do today. No, we'll just draw our sort of flow chart, and then it will magically directly become executable code. So very visionary, and I just love the comment at the end, which also shows some of the sort of cockiness of researchers, of course. And it's like, yeah, we've kind of solved the whole GUI thing now, so we're going to move on and do, I guess, speech recognition next, and then maybe handwriting recognition. And if you have like a smartphone, that is still even maybe now it's gradually becoming usable for like the general public, but it has taken a long time, like 50, 60 years.
This content was provided by RWTH Aachen University.